So we have a little video for you today on Introduction to Triangle Sum and Exterior Angle Theorems. And so in this little ditty here on the left, it's kind of cool. It's fun to do this in real life also. If you have a triangle and you rip off all three corners, like they did right here, and then you stick the corners together, it will always be a straight line. Doesn't matter what kind of triangle it is. Could be an obtuse triangle, could be a right triangle, could be an acute triangle. If you rip its limbs off, really its angles, and you line them up like that, it will always make a straight line every single time. So taking a look at what we've got on the right, when the angles of triangle ABC are arranged as adjacent angles right here, the three angles form a straight line. Incredible. The angle measures of a straight line is 180 degrees. So measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. Super interesting, huh? So the triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. Basically, that means that a triangle has 180 degrees if I add up all the angles on the inside. If we were trying to compute or determine the measure of angle B, we would say the measure of angle B is going to be 180 minus whatever A and C are. We would subtract both of these from 180, and that would give us the angle measure for angle B. So we would have to subtract both A and C from 180 to get the angle measure of B. And if the measure of angle A is 40 and the measure of angle C is 35, let's do a little bit of math. So we would see that the whole triangle, it has 180 degrees on the interior. We would subtract A, which would be 40, and we would subtract C, which would be 35. And the reason I'm writing it like this is because I want to get the sum of A and C before I subtract it. And so I would have 180 minus 40 and 35 is 75. That would leave me with 105. So again, if this one was 40 and this one was 35, together those make 75. Whatever is left has to make it to 180, so angle B has to be 105 degrees. And I think I could do the math on here if I wanted to. 180 minus 75. Let's try that. Ding. Yep, it works. So a triangle has angles that measure x, 2x, and 84. Don't get tripped out by the fact that there are variables there. Select an equation that could be used to solve for the value of x in the angle measures. Well, if we have a triangle essay, and we know that all three angles in a triangle add up to be 180 degrees, we would be able to say that the x, which is one of those angles, plus 2x, which is another angle, plus 84, which is our third angle, these three angles together, when I add them up, must be 180 degrees. And so I'm going to look for an equation that is similar to this one. It doesn't necessarily have to look exactly the same to be correct, but we're going to see if we can find something that looks like what we've got there. So you'll notice that they have combined like terms, the x and the 2x, to make 3x. So let's go ahead and do that ourselves. So 3x plus 84 equals 180. And so I do see 3x plus 84 equals 180 right here. So enter the value of x in the equation you selected. And so if we were to do this math, we would see that we would need to subtract 84 from both sides, which would result in 3x equals 96. We would also see that we need to divide by 3 on both sides, which would give us an x value of 32. So our x value is going to be 32. About that. Then lastly, the acute angle measures of the triangle with angles that measure x, 2x, and 84r, or the actual, instead of cute, the actual measures are what? And so we need to recognize that I can take this 32 that I have just found, and I can replace x with it to find the measure of those angles. So if I replaced x, so if I've got angle 1, that's not the tool you want, Schläger. I've got angle 1 is x, angle 2 is 2x, and angle 3 is 84. So if I was to draw a little sketch, this could be 84 degrees, this could be x degrees, and this could be 2x degrees. So I know that x is 32, so obviously angle 1 is going to be 32 degrees. Angle 2 is going to be 2x, so 2 times 32, or 64 degrees. And angle 3 was already given at 84 degrees, and so I've got 32 and 64. Let's test it really quick to make sure that it adds up, because those three together should sum to be 180 degrees. So let's do 32 plus 64 plus 84. This will tell us if we did it right. Do those add up to be 180 degrees? See, 32 and 64 is 96. 96 plus 84 is 180 degrees. I'm betting that we did it correctly. So 32 and 64 will be the actual angle measures. 32, 64, and 84. Winner, winner, chicken dinner. Okay. Next bubble. Run to the next bubble. Deriving the exterior angle theorem. So in the diagram below, angle 1, angle 2, and angle 3 are the interior angles of the triangle. Angle 4, 5, and 6 are what we call exterior angles. And so basically the way that angle 4, angle 5, and angle 6 were created is we extended one of the lines in the triangle past the corner. So like this line extended past here, so now that's an exterior angle. This line extended past here, that's an exterior angle. And this line extended past here, that's an exterior angle. So we have an exterior angle of a polygon is an angle between the sides of the polygon and the extension of its adjacent side. That's a really fancy way of what I just described. It is formed by extending a ray from one side of the polygon. So exterior angle, exterior angle, exterior angle, they were created by making these lines longer, is basically what we're saying there. Remote interior angles of a triangle are the two angles that are not non-adjacent to the specified exterior angle. For example, in the diagram above, angle 1 and angle 2 are non-adjacent to angle 4. So when angle 1 and angle 2 are non-adjacent, or they are not next to or touching angle 4. So they are remote interior angles when paired with angle 4. For angle 6, angle 1 is right next to angle 6. So it is not going to be a remote interior angle. Angle 2 and angle 3 would be the remote interior angles for angle 6 because they are not adjacent to it. So for angle 4, we have 1 and 2 are remote interior. For angle 6, we have 2 and 3 are remote interior. And if we were to look at angle 5, we can see that angle 2 is adjacent to angle 5. So our remote angles when we're talking about angle 5 would be angle 1 and angle 3. Pretty sick, huh? So as we talked about in the last bubble, the triangle sum theorem says that angle 1 plus angle 2 plus angle 3 must make 180 degrees. Now this is, I'm going to kind of talk you through this piece because we're going to do some sense making here. So one thing we need to be having an understanding of, and I'm actually going to pull this up here and do this on the iPad first. One thing that we need to have an understanding of is that those interior angles of a triangle do make 180 degrees, but we also have other angle relationships here that form 180 degrees. And so let's talk through a few of them. So we're just going to go with a few examples of what makes 180. So measure of angle 1 plus measure of angle 2 plus measure of angle 3 is 180 degrees. But I also see that these two angles here make a straight line. So the measure of angle 3 plus the measure of angle 4 make a straight line. They are a linear pair, so they are also 180 degrees. The same is true for angle 1 and angle 6. Measure of angle 1 plus the measure of angle 6 is equal to 180 degrees. And the same is true for angle 2 and angle 5. The measure of angle 2 plus the measure of angle 5 is 180 degrees also. And the interesting piece here that we could sort of experiment with a little bit is that if I had angle 1 plus angle 2 plus angle 3 makes 180, but I also have angle 1 and angle 6 make 180. If I pair these two together, these two are both equal to 180. So it must be true that these two and this one are the same, because we're adding them both to angle 1, and in both cases we get 180. So the measure of angle 6 must be the same as the measure of angle 2 plus the measure of angle 3. So what I'm hoping you're seeing is that this exterior angle is the same measure as the sum of the two remote interior angles. Because if I add those two angles inside the triangle to angle 1, I get 180. And if I add angle 6 to angle 1, I also get 180. So since these both added to angle 1 make 180, these two must be the same as each other. So we can make the statement based on what we've just done, that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 6. Because this plus angle 1 makes 180, and this plus angle 1 makes 180. There's some other relationships here we are going to run through. I'm going to pause for 1 second so that I can undo some of my highlighting here, and I'll be right back. Okay, so we did the measure of angle 2 plus angle 3 makes angle 6, which was pretty cool. Let's move on and talk about another one. So I've got angle 2 here. When I add angle 1 and angle 3, I get 180. If I look for angle 2 down here, if I add angle 5, I also get 180. So let's highlight that. We've got this guy again, and we're looking at this one. Angle 2 plus angle 1 and angle 3 together make 180. Angle 2 and angle 5 also makes 180. So I could say that the measure of angle 1 and the measure of angle 3 is the same as the measure of angle 5. Because when I add either one of them, this one or this one, to angle 2, I get 180. So their values must be the same. And I'm going to pause once more so I can undo my highlighting again. And for our last one, we have talked about angle 2 and we've talked about how angle 1 plus, we've talked about angle 1. Let's move on and talk about this one right here, angle 3 and angle 4. So what we have got going on, we're going to compare it to this top one again. We see that if we look at these two, if I add angle 1 and angle 2 to angle 3, I get 180. And if I add angle 4 to angle 3, I get 180. So I could make the statement, similar to what I have before, that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Because if I add this to angle 3, or if I add that to angle 3, I get 180. So looking at these three statements here, 2 and 3 is the same as 6. The exterior angle has the same measure as the sum of its two remote interior angles. Angle 1 and angle 3 is the same as angle 5. So 1 and 3 are the remote interior angles to angle 5, which is an exterior angle. The exterior angle has the same angle measure as its two remote interior angles. And then lastly, angle 4 is our exterior angle over here. It has the same measure as the sum of the two remote interior angles, which are angle 1 and angle 2. This is what we call the exterior angle theorem. And I'm going to go through Mathia and finish this sucker up. I think I did a pretty good job explaining that. Oh yeah. Okay. Moving on, everyone. Because angle 4 is formed by extending the ray from the side of the triangle, angle 3 and angle 4 form a straight line, a linear pair. So the measure of angle 3 plus the measure of angle 4 must be 180 degrees. By substitution, angle 1 and angle 2 and angle 3, I don't know what the options are going to be. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 is 180. So measure of angle 3 and angle 4 is also 180. So let's write this out really quick on our iPad. So we have, darn you, iPad, come back here. So we have got a couple statements here. Measure of angle 3 plus the measure of angle 4 equals 180. We also have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. So since these are both equal to 180, they must be equal to each other. And we can make that statement by substitution. So the measure of angle 1, darn you, highlighter, okay, there we go. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. Because since this is equal to 180 and this is also equal to 180, they must be equal to each other. Oop, there we go. So using the properties of equality to subtract equivalent values from each side of the equation, so we've got a 3 over here and we've got a 3 over here, we could subtract measure of angle 3 from both sides. We would be left with the measure of angle 4 on the right side, and we would still have the measure of angle 1 plus the measure of angle 2 on the left side. Oh, look. It's just like this equation here that we figured out earlier without you, Mathia. There's also two others that we figured out, everyone, that we used the exact same process to figure out. So the exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. I said that earlier, I think in a more friendly way too. So use the exterior angle theorem in the diagram on the left to complete each statement. Measure of angle 1 and measure of angle 3. We already sort of did that. Measure of angle 1 and measure of angle 3 is the same as the measure of angle 5. The reason we know is that angle 5 is the exterior angle. 1 plus 3, those are the remote interior angles, and so if I add them up, they will be the same as angle 5. I don't even know how to enter that. Oh, it already has the angle symbol, so it's the same as angle 5. Pow! How about that? So measure of angle 2 plus something is measure of angle 6. We figured out that 2 and 3 together make angle 6. Let's check it on the diagram again. So angle 6 is the exterior angle. 2 and 3 are the remote interior angles, and so the value of 6 will be equal to the value of 2 plus 3. So measure of angle 2 plus measure of angle 3. And that's it for this workspace. Dun, 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 dun.